Allora, prima di tutto rinnovo l'invito a lasciare feedback per i talk che gradite o non gradite, insomma lasciare un feedback su JoinD. Poi passo a presentare Federico Campoli. Adesso parliamo un po' di database,
data recovery
e di Postgres.
Di Postgres. Questo talk lo faccio in inglese, bello serrato, rischio di non farcela con i tempi. Alright, so we are talking about Postgres, Patroni. How many Postgres users? Wow. Love you. Before starting, let's talk a little about me. So this is me with my kitten, no longer kitten cat, named Ozzy. I was born in 1972, 50 years old this year. Passionate about IT since 1982. Joined the Oracle DBA Secret Society in 2004. In love with Postgres since 2006. And I have a Postgres tattoo on my left shoulder. So I really believe in PostgreSQL. And also FreeBSD. I love FreeBSD. Freelance, DevOps, data engineer. I work mostly with Postgres. If you need any help, give me a shout. Because, yeah, those are my contacts. My blog, not really updated. Mostly technical in English on PostgreSQL mostly. Twitter, GitHub with several projects. The example we will see today is on GitHub. I will give you the URL later. And LinkedIn, YouTube with my sloppy guitar technique. I started playing the jazz guitar since last year. So yeah, I have some standards with myself already. So I organized the presentation like the titles of Tron movie, references to Tron movie absolutely wanted. Greeting programs, the grid, the lifecycle maze, end of line, and fight for the users. We will see how Patroni can help us to protect our data under HA, and how pgBackRest can be coupled with Patroni to have a disaster recovery capabilities. Because Patroni doesn't implement the DR. So, greeting programs. So, PostgreSQL. Enterprise class RDBMS, fantastic product, the best gamble I've ever made in my life. I started with Postgres with the 7.4, ACID compliant, HA and DR, but with just one little catch. No automated backup or failover implemented inside the native engine. So how do you work with with Postgres at this level? You can bring your own tool, shell script, manually operated, Nazgul summoning. No, this is something I usually explain during my training. But at the end of the story, I say, you know how it works, do not use it. Use automated with third-party tools. There are a lot, they are all good. Patroni is slightly better, I love it for some reasons, we will see later. We have Rep Manager, PG Auto Failover, PostgreSQL Automatic Failover, PAF, and our friend Patroni. Why Patroni is so amazing? Because it's designed to be a completely management system over PostgreSQL. So you give all the power to Patroni. It's developed by Zalando. It's a very good one. Is developed in Python, supports for DCS variable, different flavors. So you can have etcd, console, zookeeper. You can also use a Raft native to Python, require a specific library for using it. Automated bootstrap and replica setup. Failover switchover completely automated. Centralized configuration for PostgreSQL. This is very important because some parameters in Postgres need to be exactly the same on all levels. Otherwise, one of the nodes would refuse to start. For example, if you assign too many connections on one node and less connection on another one, the standby will refuse to start if the max connections on the standby are lesser than the primary. So with this way, all the synchronization, all the configuration is synchronized in one single point, the DCS. Very resilient to split brain. The system will avoid the risk, it will completely remove the risk of writing into two masters at the same time. HA proxy can be, I seen HA proxy in Georgia presentation. I spotted into that giant diagram. And HA proxy is an HTTP proxy for routing automatically the connection into the active primary. So it can be coupled, but we will not cover this part today because there's a lot of stuff to do. Caveats. Everything is managed by Patroni. So you need to change completely your point of view. You need to trust the tool and use the tool for managing all your PostgreSQL. The documentation may be unclear. There are some parts that is quite difficult to understand, but the community is very helpful. So interacting with those guys, the Zalando guys in particular, they are very kind and very useful in helping through the unclear parts. Another thing I found, because I use a lot automation tools, Ansible is my tool of choice. Automating the API call is quite complicated because the client is always interactive. Patroni CTL, the administration tool, is interactive. So you need to implement your API call via something else. CURL, Ansible URI module. The example uses the Ansible URI module for accessing and rewriting and storing the Patroni configuration when changing stuff. Now let's speak about backup. How many of you are doing backup? Do you test it? So you have no backup. In short, if you don't test your backup, you have no backup. So let's speak about some options in PostgreSQL. pgdump is the historical backup way, is logical. But do not consider pgdump a safe way to save your data unless you want to restore at the snapshot of when pgdump was started. You will lose all the data in the middle between the moment you have your crash and the last pgdump. So it's useful for other things like detecting silent block corruption. In particular, if you are using the checksums on PostgreSQL, because you are using the checksums, right? It's a very good thing to use. pgdump can just read all the blocks, and any error at block level, it will be logged into PostgreSQL log, and you will get it. So it's still useful, but it's definitely not a backup tool. So normally the backup is made in a physical way. We save the data files, and so we can use pg-based backup, Parman, wall-e-wall-g, pgBackRest. All these tools work on the same concept, something already built in PostgreSQL. So the point-in-time recovery, the archival, the start and stop backup is internal to PostgreSQL. Those tools automate all the process for executing the action in the right order and saving the right data files for ensuring your data is completely restorable. So let's speak about pgBackRest. pgBackRest is simple, reliable solution for automating your backups. And this is incredibly true. It's community driven. Is a physical backup tool, as I said before. Implements the disaster recovery with point-in-time recovery. So you will lose only the last unarchived WAL file, 16 megabytes at most, when you are doing the backup in this way. And you can restore at any time between your last backup, last valid backup, and the moment you get the crash. It's very useful for restoring, for example, dropped tables. You clone the database, you get the data, and then you restore what is being dropped. It supports differential, incremental, and full backup, very efficient. Parallel job configurable, so it can save the data in parallel. Can back up from the standby server, even better. You do not overload the primary when taking your backup. Asynchronous while push and pull. This is very important for high write activity databases. The archival process, it can be expensive in terms of operating system, and it can slow down the archive process. So asynchronously, pgBackRest can archive with hard links these files and then push all together into the repository. Very fast, very efficient. It was developed initially in Perl, but now is completely migrated to C. It uses an ini-style configuration, is available within the pgdg, deb, and yum repositories, supports cloud backup natively, GCP, S3, Azure. Multiple repositories configurable, so you can have a local backup, cloud backup on GCP, another cloud backup on S3, another one in Azure. And this is the thing I like the most. Self-contained backup repository. If you have the backup repository, you need nothing else except the pgBackRest executable for restoring your data. No system, no catalog stored somewhere else, no complex configuration. You need only the backup repository and pgBackRest, plus the configuration file, of course. There are some caveats, obviously. Configuring remote backups, it can be complex if you are using SSH. Recently, they added the TLS server for simplifying this process and speeding up the operation. When configuring the asynchronous archive, there is some risk if the WAL files archival storage reaches the limit of archive push queue max. If this happens, some WAL files won't be archived, invalidating the point-in-time recovery. So you need to size correctly this value. And as usual, RTFM. Always RTFM when doing this sort of stuff. If you want some advanced topic, you can point this YouTube video. It's from Stefan Ferkot, one of the maintainers of pgBackRest, with the advanced topics. It's very interesting, in particular regarding the multiple repository setup. So let's move into the grid. What we want to do. This is an horrible diagram designed by me. I'm definitely not an artist. So what we want to do, we have 3 nodes, Patroni 1, Patroni 2, and Patroni 3. On each Patroni, we have a Postgres installed and running. On each node, we have an etcd node for creating our etcd cluster. The number of the etcd nodes should be odd, so they can elect a new leader in case of crash. So they are very lightweight. They can be installed onto Postgres databases machines. So it's very simple. We have a streaming replica moving from the leader to the standbys. And therefore, we will use Rocky Linux because CentOS is no more. And Rocky Linux, it was created from the CentOS ashes. Very good distribution, by the way. So we have Patroni 0, Patroni 1, Patroni 2. And the steps for setting up our Patroni cluster is very simple. Deploy the machines with Terraform. In the example, I provide the entire Terraform infrastructure definition with the readme for using it, so you can use it if you want. Then install a TCD on the nodes. Configure and start a TCD. Install PostgreSQL and Patroni on the nodes. Do not configure anything else except Patroni. Start Patroni and profit. Very simple. Let's see. So this is one fragment of the Terraform configuration. Because Terraform supports the loop, I decide to use the count variable, defining the number of Patroni nodes into the variables of the my Terraform infrastructure. And this thing is used for generating the name of my instance. So Patroni instance, I decide to use an E2 small because I need to install something. The micro is too lean in terms of memory. It crashes constantly when running DNF. Boot disk Rock Linux 8. We have a network name configured here and the SSH key for accessing. And then we have the firewall. The firewall is split it into parts. One for accessing via SSH, because the example provided on GitHub uses Ansible for deploying the rest of the entire thing. It's a very good idea to use Ansible. And also we have the internal firewall for opening the required port for the Patroni node. If you see here, 5432, this is the default for PostgreSQL. 6432 is not used in this example, but usually is used by HA proxy, or vice versa. They can be swapped, but those are quite common. 8008 is the default port for the Patroni REST API check, and is used by Patroni and by HA proxy to determine which one is the primary within the Patroni cluster. Those two ports are used by etcd. So those are the things we are using. etcd, unfortunately, on Rocky Linux is not available as a package. So we need to download from GitHub and configure it. Not a big deal. Download the binary, extract somewhere, link it, symlink, and then configure the environment file. etcd supports two ways to configure the service, YAML or via environment variables. I try to use YAML, but it looks like systemd doesn't like the parameters for the YAML for the YAML configuration file. So and then I got the unit file from the CentOS that exactly uses this same strategy. So basically, what we have here, we have the etc data dir, the list and peer URLs, and also we have the initial cluster name with the etcd name, which need to be unique within the same cluster. And then we have this thing, the unit file. It just called etcd define the gomaxprox. And in particular, this thing, the environment file we've seen before, is saved somewhere in etcd-config.env, and systemd uses this environment file before calling the etcd start. So everything will be fine. And after starting etcd, it's possible to check the etcd health with this command. This is the command for the API version 3, because I used the etcd3 version with the API version 3 for this example. And then the next step is just install the repository for PostgreSQL 14. It's available on the PostgreSQL official repository. We download the RPM. It will configure for us, and then we will install PostgreSQL. But also we need to disable this module in DNF before running the install. Otherwise, there will be some conflicts. Then, for using Patroni, we need the EPIL release. There are some libraries required by Patroni, and not just by Patroni. Even my pgChameleon, the MySQL to Postgres replica, is packaged and requires the EPL, because it's just too new in terms of Python stuff used by this tool. So it's just install the EPL, install Patroni, and Patroni etcd is the module for accessing etcd. In case you are using Zookeeper, it will be Patroni-zk. If it's console, Patroni-console, and so on. It's very modular. Then we start the difficult part, configuring Patroni. Patroni uses a YAML file for configuring the service, and everything is split in pieces and variables and parts. Scope, namespace, and name is just the structure of the directory created into etcd. So we have namespace, the grid. The scope is our Patroni cluster. So we have the grid, Flynn, and then the name of our single node, Patroni-0, which need to be unique within the Patroni cluster. Logging, the REST API I mentioned before, with the listen and connect address on that port. The etcd hosts, note etcd3. If you are using etcd with API 2, you need to remove the 3. That's it, very simple. And then we have the bootstrap part. The bootstrap is when Patroni starts for the first time. It means empty configuration in etcd and no data directory into the destination for the data area. So Patroni will initialize completely from scratch the entire situation. And then it will run through the bootstrap section, moving through this particular part. So it will store these variables, and also it will execute anything under the PostgreSQL key with the, whether it has to use pgRewind or slots or parameter, the wall level. So everything needs to be initialized from scratch. It should be defined under bootstrap. The method for the bootstrap, so we want to initialize from scratch, we will use initDB. We can also specify options for initDB, for example, the encoding UTF-8 and what I mentioned before, data checksums. The data checksum must be enabled at initDB. They can be switched on later, but it needs the database to be shut down. So if you are starting from scratch, use the checksums. Is very good to use, very good to have. PGHBA configuration for allowing a connection for replication and strong encryption. Do not use anymore MD5 unless you have very old legacy systems. MD5 is no encryption. Scrum SHA 256 is a very good thing. So then we have a replica of the PostgreSQL bootstrap part. And this is the exact configuration for Postgres. When I said before, you need to use Patroni for configuring your Postgres. That's what I mean. You need to manage everything about Postgres via Patroni configuration file and also via DCS direct access through the Patroni CTL file, the Patroni CTL command, or using the API call for rewriting the Patroni configuration. And this is the part, so we have basically exactly the same, plus extra stuff like the data directory, where is located the PostgreSQL binary stuff. Because we can have multiple versions, multiple major versions, we need to tell Patroni which one we want to use. Because we cannot start a 13 with the binary, so 14 or something else. They are completely incompatible between major versions. So we need to specify what exactly we want to use. Authentication. So basically these are the super user, the user used by the replication, and the rewind for rewinding the old primary against the new primary when remastering the database. And finally, we have the other parameters. So PostgreSQL parameters, wall level exactly the same like the other one, plus other tags. After creating the Patroni configuration file, we create the unit file, not created because this is a unit file available into the package. So you just need to copy into the right place. And this one is just set some stuff and then start the process by specifying the configuration file we created before. Sorry. So this is the rest of the systemd service part. So at this point, we just daemon reload, systemctl daemon reload, enable Patroni and start Patroni. What happens when the first Patroni node starts? It will access etcd, it will see there's nothing inside, it will create the structure, the directory structure for the usage of Patroni, and it will also acquire the leader token. It will see, okay, I am the first, there's nothing else, I am the leader. And then it runs initDB, the bootstrap method we specified in the configuration file, and at the end of the story, at the end of the process, we will have, with this nice command, we will see Patroni 0 is the leader. When we start the other two will try to acquire the token, but they will see the token is already by the Patroni 0. And then they will configure as a replica by using PG-based backup, basically physical block streaming across the Postgres connection. So now let's add our GCP bucket and pgBackRest into the equation. So First, we need to configure the software. Install pgBackRest on the Patroni server, create the GCP bucket, create a new service account on GCP, and then create a new service account, generate and save the service account access key in JSON format, configure pgBackRest for using the GCP bucket, configure Patroni to use pgBackRest, and run pgBackRest first backup and profit. I think I need some. Oh, I'm literally. So next step. Next step is so installing pgBackRest is very simple. Just DNF install pgBackRest. And we need to configure pgBackRest. After the installation, we will get the pgBackRest configuration file in etc. We have a global section where we will configure the repository with the GCS bucket key, the bucket name, the bucket key, the JSON key I mentioned before, the repo retention full, how many full backups we want to keep. And then we have other stuff like backup standby. And then we have this other part, which is called stanza, strofa, literally. Stanza in English means strofa in Italiano. And is sort of poetry reference. So into the stanza, we have the configuration for the backup. So we have the PG path, where is located the PG path, the port, the user to use for backing up. But because this is the local instance, we specify no host, because otherwise pgBackRest will not understand we are working locally. And then we have the rest, PG2 for Patroni 1 and PG3 for Patroni 3. We can also set up the PG pass for configuring the passwordless access in the PSQL client. So this is the GCPK JSON with something omitted and something redacted. And then at this point, we need to edit the configuration of Postgres. So we will use Patroni. So we will use patroni.ctl with the configuration file and the command edit config. This will open the DCS, and we will edit the DCS contents. And we will change the archive command to archive command equal to pgBackRest stanza equal Flynn archive push %p. The marker will be replaced by the archived WAL file automatically by PostgreSQL. Then we need to create the stanza, pgBackRest stanza Flynn stanza create. So it will create the structure into the bucket, and then we will run the backup with just pgBackRest backup. This is all the output. I increased a little the log, and at the end of the story, the backup is finished in 8 seconds. And then we can check the backup is here. With the pgBackRest info, we will see we have one archived file, one WAL file. This is our backup. Original size 25 megabytes, and the backup set is 3.2 megabytes, because I forgot to mention pgBackRest compresses the data files. And now we are at the end of line. Il backup è quella cosa che andava fatta prima. So backup disaster is not a matter of when. It's not a matter of if. It's a matter of when will happen. Disaster always happens. So be prepared with a good backup. So let's put in these terms. Somebody has run Terraform destroy target against the Patroni nodes, and you have lost all your data. How do you fix this thing? Well, install create again these nodes. Well, I suggest using a mallet against the person that destroyed that thing, probably some torture or physical punishment. But on the IT infrastructure, let's install and configure etc. Same steps of the other one we have seen before. Install and configure, deploy the Patroni nodes, install and configure etcd, install and configure pgBackRest, create, install Postgres and Patroni, configure Patroni to bootstrap from pgBackRest. This time we are not using inidb, but we are bootstrapping from pgBackRest. Start Patroni and profit. So, after installing the nodes and pgBackRest and everything and configuring everything, check you can access the repository. pgBackRest info, it will show something like this. So you have a backup, you are safe. Then we need to create a bootstrap custom script for Patroni. This is extracted straight from the manual online. Is a convoluted way for accessing the optargs from the Patroni shell call for determining the data directory and the scope. What's important is the scope. If you have noticed, I named the stanza same name of the Patroni cluster because this is my scope. So this script, it can dynamically call pgBackRest with the stanza restore command without the need of hard coding into the script. Obviously, it needs to be executable. And then into the bootstrap section, we change inidb to pgBackRest, and then we specify what we want to run for pgBackRest. Our command, the one we have seen before, plus other parameters. And also we specify the restore command for getting all the archives from the pgBackRest repository, because we don't have any other mean to get this data. Similarly, the create replica method is by using pgBackRest, nothing else. We need to create the data directory, and we need to be sure that this data directory is accessible only by Postgres, otherwise Postgres won't start. pgBackRest, unfortunately, is very restrictive in these terms. Expect an empty data directory when restoring with no delta option, but with delta is more permissive. So we start Patroni, and the difference, when we started Patroni initially, I haven't shown you, but the command was initializing new node, bootstrapping. In this case, we are running the custom bootstrap script. It means it's using GCP for restoring our PostgreSQL. And at the end of the process, we will get a new running leader with a different timeline. It means a successfully failed over. And then when we start Patroni onto the other two nodes, we will get a create a replica first, and then they will follow the timeline number 2. And we are survived. This is the repository link for the example. You can get basically everything working. And wrap up. Patroni and pgBackRest are amazing. It requires a change of point of view. Doesn't implement the DR Patroni, but pgBackRest does. This example is absolutely not exhaustive. It misses a lot of pieces. And using tools like Puppet, Ansible for deploying this stuff is a very, very good idea. And always read the funny manual. So that's all. And any questions? Ovviamente le rispondo in italiano, se ce ne avete.
Domande?
Prima hai menzionato hproxy, ma perché utilizzi quello come proxy?
Hproxy.
Sì.
Perché hproxy è in grado di
no, scusa,
andare...
non perché usi quello, ma utilizzi hproxy come proxy.
Sì, è consigliato usare hproxy con Patroni, a meno di non usare un metodo di connessione che sia capace di capire qual è il primario. Okay. Per esempio, se te utilizzi JDBC ha un sistema per dire voglio collegarmi solo al primario. Con hproxy invece, hproxy che chiama Patroni, controlla lo stato dell'HTTP dell'API e capisce dove deve andare a finire. Comunque sì, hproxy è il tool consigliato e ci sono gli esempi. Altri tool purtroppo non lavorano così bene.
Altre domande?
Ho notato che con pgBackRest hai usato il val archiving, hai un archivio val da qualche parte?
Il cosa, scusa?
Un archivio dei val, dei dati?
Sì.
Okay. Da quello che so, pgBackRest necessita dell'archivio. Volevo sapere se sai se questo è ancora vero, se ci sono modi per fare quello che stai facendo con i backup senza avere un archivio completo dei val.
No, l'archivio è comunque necessario, non è legato a pgBackRest, ma è legato proprio alla struttura del point in time recovery, ma non è di Postgres, lo è MySQL, lo è Oracle. L'archivio dei log è necessario se tu vuoi essere in grado di fare una recovery al momento specifico, il point in time recovery. Altrimenti ti fai uno shutdown, ti fai una copia statica dell'area dati, però è come se te facessi pgdump, hai una fotografia.
Ok.
Mi sa che ce n'è un altro, ma comunque mi sa che
magari un'altra domanda, ci sta.
Se ci abbiamo ancora un attimo.
Non avevo visto.
È Patroni che si occupa di eleggere il nuovo master in caso di problemi sul cluster Postgres.
Sì. Praticamente quando perdi il master, Patroni non fa altro che eleggerlo utilizzando sempre un algoritmo Raft e nel momento in cui questo viene scelto e c'è i proxy, già trasferisce le connessioni anche se non è ancora in failover, in modo tale da evitare di poi andare a scrivere sull'eventuale master se dovesse tornare in piedi. Se torna in piedi il master, si riattacca automaticamente poi al nuovo leader.
Ultima domanda.
Sì, ciao, mi chiedevo se ci sono dei requisiti di latenza tra le repliche, quindi se possono essere distribuite geograficamente.
Quello dipende da te. C'è un pezzo che aspetta che provo a ritirarlo. Dunque, era... questo è ancora pgBackRest. Dunque, eccolo qua. Allora, eccolo qui. Maximum lag on failover, questo qui.
Ok.
In pratica, te determini quanti dati ti vuoi perdere durante il failover. Quindi se hai una replica geografica, metti un valore di dati importante in modo tale che sei sicuro di poter fare il failover. È sempre il solito trade-off.
Ma le transazioni sono affette dal tempo di replica o il commit avviene dopo?
Allora, in realtà te
per
normalmente,
ACID dovrebbe essere...
per come conosco la streaming replica, perché poi comunque lavorano in streaming replica, nel momento in cui te fai commit e va sul disco, un istante dopo il dato è passato sullo standby.
Okay.
Poi che venga applicato non è garantito perché è completamente asincrono. Se vuoi una roba sincrona, non farlo. Perché è veramente una roba da spararsi. Bisogna veramente pianificarlo a vari livelli.
Di perdere un po' la caratteristica ACID di un relazionale.
No, è che se ti perdi uno dei nodi e non l'hai configurato correttamente, dopo non scrivi sul più primario. Quindi c'è questo rischio concreto qui.
Grazie.
Quindi va pianificato, RTFM sempre. Va bene.
Grazie.
Grazie a voi.